Algebra 1, lesson 46. So we're going to get turned over in our book to right around page 288. We're going to talk about simplifying expressions with square roots in higher order roots. So square roots, are where we're trying to find two of a specific prime number inside of a composite, right? And higher order roots might be like the third root. So we'd be looking for 3 of a certain prime factorization number, right? We could do 4th roots, 5th roots, 6th roots, all the way on up to infinite roots, okay? Typically speaking, we really don't go very high, but we can go as high as we really want. So a number has both a positive and a negative square root. So, you can see a plus or minus sign out front there. The principal square root is the positive square root of a number. So, for instance, what's the square root of 4? 2. But depending on how we wrote it, we could also get the negative 2, right? So typically, if no negative sign is present, what they're looking for or asking for is the principal square root, and that's what we calculate. So I'm not, generally speaking, the square root of 4 is 2, right? The square root of 9 is 3. The square root of 16 is, square root of 25 is, okay, great. We could keep going on and on like that. If you know your perfect squares, right, it's easy to go up. So higher order roots can be calculated in a similar way that square roots are calculated. The cube root of a number is written with a 3 out front. You'll notice that a square root doesn't have a number in front of it. It's implied when we have something like this. Okay, we know because there's no number out front that the number that is there is a 2. Okay, so we don't have to write the 2. If there's no number there, it's understood that it's a square root. Okay, but this symbol by itself is just a root symbol. Okay, it's a radicand. Is, I believe, the specific term for it. All right, so with nothing there, it's implied that it's a 2. Now, if there is a number there or even a variable there, we have to act accordingly. Okay, so we could have something like a cube root, okay, which is the number 3. And that's a little confusing because what number do we normally think of when we think of cubes? You usually think of 3 when you think of cubes? I think of 4, right? Because I think of a cube as a, as a square, 3-dimensional square. But because it's 3-dimensional, length, width, and height, it's a 3, okay? Okay, whose cube, so written as the cube root of x, whose cube is x. For example, the cube root of 8 is 2 because 2 cubed is 8. Okay, so if we broke 8 down, right, we found the prime factorization of 8, right, we'd get 2 and 4, 2 and 2. And because it's the cube root, right, we're looking for 3 of something. What do I have 3 of here? I have 3 2s, so the cube root of 8 is 2. 2 times 2 times 2 is 8. Does that make sense? Okay, and so if we were looking like for, say, the 4th root of 16, the 4th root of 16 is 2. Okay, because if I took 16 and got it into primes, I would find 4 2s. Does that make sense? So the 5th root of 32 is 2, because there's 5 2s that make up the number 32. Do we follow some of the logic here? Okay, great. All right, so the cube root of 8 is written as 3 radicand 8, or 3 radical 8. Okay, in general, when I have, the nth root of something to the nth power, those n's cancel each other out, and we get just that number that's inside, or letter, or whatever. Okay? Because essentially what we're doing is we're taking that exponent and we're dividing it by the root number. So n divided by n is 1, which brings out my variable c as just c to the first. Okay? So if I had something like, let's say, the square root of 4 squared. Those 2's would cancel out because it's 2 divided by 2. 2 divided by 2 is 1. 2 divided by 2. 2 divided by 2, not 2 minus 2, is 1. So this is just 4. And if you think about it, you'll understand, because what is 4 squared? 16. All right, so if I replace that with 16, what's the square root of 16? 4. So does this make any sense? Am I going too quickly? Makes sense. Okay. All right, so either it does make sense, or we're saying it makes sense so that we can move on and get started, right? All right, so higher order roots. All right, if we have a to the n equals b, then what we're really saying is that the nth root of b is a, or the nth root of b equals a. So the n to the left of the radical sign is the expression. In the expression is the index of the radical. The index is an integer that is greater than or equal to 2. And what we're talking about is this right here is what we call the index. That's that number in front of our radical symbol. Okay? So in the case of square roots, the index isn't written, but it's understood to be 2 whenever there's nothing there. Okay? So just like with a variable, if I said a, what's the exponent to a there? 1, right? So just like how we understand that if there's no exponent listed, that the exponent is 1, when there's no root number listed or index, right, it's understood to be 2. Okay? Does that make sense? All right. I think this is our the last slide. So roots can be written as fractional exponents. So if we consider this, if we had x to the 1/2 squared, right? What am I doing? Now that should be an exponent, right? Hopefully we understand that the 1/2 is an exponent, right? What am I doing between the 1/2 and the 2? Multiplying. What's 1/2 times 2? 1, right? And if I look at it, would be what? 2 halves, correct? 2 times 1/2 is 2 halves. 2 divided by 2 is 1. Okay, we're getting a little bit of classroom participation. So using the power of a power property, the expression simplifies to just x, right? Because x is x to the first. This is equivalent to this statement, the square root of x equals 2, because if you'll see in here, what would the index be in square root of x? Okay, the index would be 2. What would the exponent be? What would it be? 1. Okay, so if I wanted to take this out, I would take 1 divided by 2. All right, so you see, I can go back and forth either way, right, whenever I see something as a fraction. So let's change this a little bit. Let's say we had x to the 3/4. Okay, it looks like 7. So let's just leave it as 7. Okay, we have x to the 3/7. Can I write that as a radical expression? What would it be? Keeping in mind that x to the 1/2 is the square root of x to the first. All right, so the 7th root of x cubed is equivalent to x to the 3/7. You're absolutely right. All right, do we want to try another one? Yeah. All right, so let's say we had, let's go back the other way for a second. Let's say x to the 2/3. Actually, no, let's say we had x squared, the cube root of x squared. What is that as a fraction, or x to a fraction? X to the 2/3. Good. All right, let's try another one. Let's say x to the 4/5. What is that as a radical expression? X to the 4th with 5 as my index, right? So it would be the 5th root of x to the 4th. Does this kind of make some sense? We can go back and forth either way, right? Yes? No? Kind of?
So the numerator is always on the inside?
Yeah, the numerator will always be the exponent on the inside of the radical, okay? The denominator will always be the root number, okay? So we should be able to go back and forth, okay? Whichever's going to help us solve, okay? So here where we have the nth root of b to the first, that's the same as b to the 1 over n. Okay? Pretty good there? All right? Let's work out a couple of questions. Oh gosh, this is getting hard to see. Lesson 46, right? Okay. So what's the square root of 49? 7, right? And I bet I still can't write on our board. Nope. All right. But we all know square root of 49 is 7. All right. Let's see. We have negative 343,000 to the 1/3. Okay. Let's see. We've got that. Let's go ahead and pull back to a page over here. We have negative 343,000 to the 1/3. Could we write that as a radical expression? Anybody know? Okay, so we need to know what some of the terminology is so that you can say what you mean and I can understand what you mean. Radical? Okay, radical. Index? All right. So Jeremy's answering a lot of these questions. I'm not really hearing a whole lot from everybody else. Can we plug this in our calculator? How? I mean, we know how to find a square root in our calculator, but how do we find a cube root in our calculator? All right, well, let's see. Not necessarily. So I'm going to hit 3. Actually, I don't even have to do that with cube roots. If I hit math, I can go down here, and it's got on number 4 a cube root. Now, let's say it wasn't a square root and it wasn't a cube root. How would I get something higher than that? Let's say 5. Now, on your newer calculators, you should be able to get an option where you can just plug it in. But for us, on these old calculators, I might have to do something like this where I plug in that root number like 5, then hit math, and then go down here to number 5. Right, and that will give me my 5th root. And what it's saying is that 5 is the index. Okay, but we just want the cube root. So we're going to hit math. We're going to hit cube root of negative 343,000. All right, and I get negative 70. All right, now let's go ahead and try this out a little bit. Okay, and see if we can solve this kind of pencil paper. 343,000. Negative 343,000. What could we divide that by? Probably 5, right? 5 would be a good prime. Okay. What's negative 343,000 divided by 5? We're probably going to get a pretty big number here. So I'm going to actually take this. I'm going to start up a little bit higher and a little bit smaller. Negative 600 and okay, negative 688,600, right? Negative 68,600. Okay, negative 68,600. Okay, and we could divide that by 5 again, right? Well, yeah, but if I do it by 10, that 10's not a prime, and so I'm going to have to break that 10 down, right? All right, so what do I get there? 7,000, negative 13,720. Okay, well, I should be able to divide that by 5 again. Negative 2,744. Is that, we agree to that? All right, well, I can divide that by 2. Negative 1,372. Okay. Okay, well, that ends in 2. I can divide that by 2. Negative 686. Well, that ends in an even number. I can divide that by 2. Negative 343. Ooh, I don't know. I may have to try dividing that by like, what will that divide by? Will that divide by 3? No? Will it divide by 7? Negative 49. Okay, well 49's nice because that'll divide by 7 and get me negative 7, right? Okay, now this said cube root, correct? So I need 3's of things. All right, what do I have 3 of? I have 3 5's, right? So that comes out as 1 5. I have 3 2's, okay? And I have, well, really that's going to come out as negative 7. Okay? Does that make sense? Okay? So, what's 5 times 2? 10. What's 10 times negative 7? Negative 70. So do we understand how to get negative 70 and how that works in an expanded format? Okay? So hopefully that helps to see something. Not only we know how our calculator can do it, but we know how it's getting it. Okay? All right. Do we want to try to work out a problem or two from our homework? Sure. Okay. Let's see. Everybody wants to do a word problem, right? That's always one that kind of bugs us. But I want you guys to do the word problems, because if you don't practice the word problems, you're not going to get any better at them. So if this is one that we all miss tomorrow, then obviously I'll work it out with you. But let's pick something besides a word problem, because I want you to be able to think that through instead of me doing all that thinking for you. Well, actually, let's do in, but let's think it out together. Okay, so we've got a sculpture in the shape of a cube. Do we know how to draw a cube? How do we draw a cube? Can I get somebody up here to draw a cube for me? Anybody? How might I start? Okay, well then talk to me. How do I draw a cube? Because for me, I'm visual. I need to see this. You want to draw a cube for me? All right, come on up here, Tiffany. Show me how to draw a cube. Let's make it big. All right. Bring it kind of over here in this area. Here, let me get you a color there. Okay, good. All right. All right, good. That'll work. Okay. All right, so a sculpture in the shape of a cube. Well, what do we know about a cube's sides? They're all the same size. They're all equal to each other, right? The geometric term is congruent. So just real simply, like I know that the length and the width and the height are all the same, correct? Okay, cool. All right, so a sculpture is in the shape of a cube and it has a volume of 1,728 cubic feet. What is the side length of the block? So we just want to know what one of these sides is. All right. Well, since we don't know what any of the sides actually are, could we represent an unknown? How do we represent an unknown? Like an X. Okay, so if I put X here, then what are these other marks then? That's X and this is X here, right? How do I find the volume of a cube? Does anybody know? Length times width times height. You're absolutely right. Length times width times height. What is the length of my cube? X. And what is the width of my cube? And what is the height of my cube? Okay, great. Is there any way of simplifying X times X times X? X cubed. Okay, so the volume of a cube could be found using X cubed, but what do we know that the volume equals? I think we already know what it equals, right? Say it for me again. 1,728. Okay. Well, is there any way to solve for X? The cubed root of X. But if I'm going to do it to the left-hand side, do I also need to do it to the right-hand side? Yes. All right. So I'm going to cube both sides. Now, let's try to do this without our calculator. Is there any way for us to find the cube root of 1728 without making our calculator do it? What could I divide 1728 by? I could divide it by 2. Okay, what do I get? You're all trying to do it inside your head. What's that? Somebody double check that. 864. Okay. What could I divide 864 by? 2, and what would I get? Okay. What could I divide that by? 2, and what would you get? What's that? 216. Okay, which will divide by and get 108. And then 54 and get and then and get and then and get. Okay. And so what are we looking for? We're trying to pull out how many of a number? 3 of a number. So do I have 3 of anything in specific? All right, so I got 3 2s here. What about what's next? I got another 2, and then 3. All right, so what that looks like is 2 times what? 2 times 3 times 2. Right? What's 2 times 3? What's 6 times 2? 12. All right, so 12 is the length of a side. So in our case, it's 12 what? What's my unit? Feet. F? Yeah, there you go. You've solved 2 questions in one foul swoop. All right, very good. So did that help, just kind of talking it through? Okay. Do you guys think you can do the rest of those on your own? Perfect.